Okay, so very rudimentary 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 counts with the ball rolling down an incline with the domino on its side, with the domino on its short edge. We calculated slopes approximately 0.04 and 0.08. It was like 0.042, 0.083. And on the assumption that my counts were about a second apart, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. You know, you can count that right there in the video and see how close I am. And I think that's about the count I was using. Well, based on those counts, we got a 30 centimeter per second squared acceleration on this ramp, 70% on the ramp with this slope, right? Now just using those 2 points, I throw a straight line through it. It has all the characteristics we want, and just totally, I didn't make this happen. I didn't do this in advance. But the graph slope turned out to be 1,000 centimeters per second, which is 10 meters per second squared, which is what we pretty much usually use for the acceleration of gravity in SI units or in the centimeter per second squared unit, which is often more convenient than this one, okay? And it, the actual is about 9.8 or 980, so that's not off by much. So it looked like we really lucked out until we thought about it. This was a steel ball rolling without slipping down a ramp, and the potential energy loss of that ball goes into its kinetic energy. There's a little bit of loss, but rolling friction is very low, so there's not much loss. Okay? And the problem with this is not all the kinetic energy. That ball is in motion in the direction we were measuring. The ball's also spinning. And it turns out that the way that was spinning, the way it was sitting down inside the track and so forth, which we will analyze later, amounts to about 30% of its kinetic energy. Well, if your kinetic energy is off by 30%, your velocity is off by 15%, ballpark. Okay? Meaning your acceleration based on that velocity will be off in a way that you can analyze, okay? Is it 15%, is it 30%? Well, think about it. Okay, so this looks like a good result. So, at first I thought, boy, I really lucked out until I thought about what I was doing. Then I realized it was just dumb luck because no way we're going to be this precise. But yeah, really weren't that lucky. We were off by probably around 30% from where we should have been. Okay? And I didn't put the centimeters per second squared because if we're comparing with 1,000, it's 1,000 centimeters per second squared, right? Okay, well anyhow, that's how you measure the acceleration of gravity, and everybody's done that, I think. Everybody has the data to do that, and everybody, kind of said last time, get me that data. Based on 3 data points obtained from lab, at least one of you got something that's pretty close to this range. I think it was around 700. You might not have gotten it, but your data indicated that. Okay? Okay. So, make sure we understand this.